Alright, so number 14 from the practice exam. So it says, which substance would undergo the following reaction? So I have some molecule, I don't know what it is, and first I treat it with ozone, and then I treat it with zinc in acetic acid, and I get these two molecules right here. Right? So whenever I see ozone with acetic acid, I know that I'm going to get ozonolysis of alkenes, right? That's what I'm going to get. Which means I'm going to have cleavage of alkenes with ozone, which is O3, and workup with zinc in acetic acid leads to less highly oxidized carbons than products from cleavage with hot potassium permanganate. So in order to know what I'm talking about there, see problem number 13, the previous problem in the same series. So basically, whenever you have ozone and then a workup with zinc and acetic acid, and you get the breaking of these molecules, whenever you use these on alkenes, unsubstituted carbons that are attached only to hydrogens, turn into aldehydes, whereas when we worked them up with potassium permanganate, they became carbon dioxides, right? Carbons, monosubstituted carbons that are only attached to one carbon and a hydrogen, they become aldehydes rather than carboxylic acids when they were worked up with potassium permanganate. And finally, disubstituted carbons become ketones, right? Disubstituted carbons became ketones with potassium permanganate as well. So looking at this, whenever you have ozonolysis or whenever you're breaking alkenes, whenever you're doing oxidative cleavage, right? The molecule broke in two. So we know it's not a ring. Rings won't break in two. If there's a single molecule, if this was a single molecule, we know we started out with a ring that had a double bond in it somewhere. But since it was it broke into two molecules, we know we had a chain that had a double bond somewhere in it that split in half. So I rearranged these two molecules that I started with, and I put the carbonyl groups right there head to head. So I had a formaldehyde and an aldehyde. So I know that before ozonolysis, this carbon right here was double bonded to this carbon right here. So I just brought that down, right? This carbon goes here, it's double bonded, this carbon's double bonded to this carbon. These oxygens were added by ozonolysis. And then, this carbon's attached to these two H's. This carbon is attached to an H. It's attached to this one, this group here. And so they want us to name what was this molecule that we started out with. The name of the molecule is 4-methyl-1-pentene. That's number E on the practice test.